All right, welcome to the second talk this afternoon, second day, UGM 2021. This is Dan Moore with the iRODS Consortium. He's going to talk about all the work he's done in the last year or so with the Python iRODS client, and we got to 1.0. There you go, Dan.
Yes, indeed. Thanks, Terrell. The Python iRODS client, which we internally sometimes call PRC, so if you hear that abbreviation, we just last week, I believe, with Terrell pulling the levers, released PRC 1.0. So this Python client that communicates with a connected iRODS server originated in its long ago years. It was a thing at Cyverse, developed Chris LaRose and Michael Gatto, whom I don't believe I've ever spoken to, but via Antoine de Torcy, who worked at Renzi on the iRODS team when I got here, and then left soon after. With his, I guess his and my shepherding it through, it's now a version 1.0. Curiously, we have 41 contributors to the thing from the community, including the community, and that's a number that cropped up during our lunch session. That's the number of releases of iRODS total also to this date. I don't know how that synchronicity comes about, but there we are. So I took it over in 2018, and there've been a few bug fixes. I think we covered this last year, in UGM, and then we've now brought it from 0.8.3 at that point in time to a 1.0 in the present, and we've added some capabilities to sort of to mirror what new capabilities exist now in the server, with 428 and 429 releases of the iRODS core and server. Let's look at those right off. Atomic metadata is a new capability with, I believe, the last release, 428. It allows you to basically put in batch form in one transaction with the server, and then also with the database, a whole bunch of add remove operations, each of which will manipulate, add or remove an ADU from an object in the catalog. This capability in the server has brought us an increased efficiency over doing the ADU operations individually, because of course each of those involves one trip to the catalog. So we've observed, hundreds of times faster in terms of this capability over the individual ADU manipulation. We also have parallel transfer, which has been mentioned now, I believe, a couple times. It is a way to connect under client control from the client library, and it's been realized in the PRC. Make multiple connections to an iRODS server or servers to get the basically your bytes to go, your file to go to the desired destination on the resource server, or to come back in the case of put and get respectively. So the good thing about this is that you don't need to learn any new calls. In 429, if you're operating with the iRODS server 429 and 1.0 of the Python client, the put and get calls should spawn the necessary number of threads to get the increased throughput. We have actually demonstrated that this has demonstrated equivalent transfer times with the multiple threads to the old high port connection. That is the old style of parallel transfer, where we opened high ports, had to make high ports available from the server for the server connections back to the client. I have not yet personally seen the 3 to 4 time speed up that is theoretically the result of that, using either old or new styles of the parallel transfer. But I'm actually working on setting up some tests in a exogeny ExoGeniNet, I think it's called, test bed that we have, where you can distribute things geographically, have a number of servers and clients. And I'm actually working on a demo of that so we can get verification of that speed up. But if you have TCP IP delays, for example, in one connection, and you can fill that up with the thread that's with multiple threads, that's good. In the in some of the new APIs in 429 that support these two capabilities we've just talked about, we've actually had to modify the Python client to adapt to a new packing use of a different packing instruction than was used in 428, so that we can insulate some of the problems, insulate ourselves from some of the problems that happen when you include, like, for example, less than, greater than, ampersand, because the PRC speaks an XML-like protocol that iRODS uses for some of its clients. So that was causing problems until we corrected that issue. So that's now baked in with, and it adapts with 429, 428. It'll work in either with either server, which is good. I'll just mention briefly that there is a upcoming, perhaps in 1.0.1, there is perhaps to be an improvement that will allow the characters of low ordinal value beneath 31, the ASCII control characters, to actually occur in object names. And that was Chris Smala's work with Sitza Snell, I believe, contributed also to that branch. And I adapted that for Python 2 compatibility. We also can do the same thing now, the computation of checksums with the server, as iChecksum, the I command, can do. And that's just the one bit of code I have in this presentation. Other miscellaneous things, we've modified ACL's reporting to be able to report basically the raw list of applied ACLs, as opposed to some baked version of it, which was causing problems for some consortium members. We can now log in via PAM from an iRODS environment.json file. That was an issue that occurred very soon after last year's UGM and was fixed and tested. We can not just configure connection timeouts, but we can adapt due to an addition from Kaivan Kamali from Penn State on the Galaxy project. He gave us a commit that would allow us to actually sense whether a connection had been way too long, sense that the server might potentially have disconnected and not use that, and therefore close it out and automatically bring up a new one, fresh one. Also, we can issue temporary passwords for users. I think that's used primarily for password reset type situations. We can be a lot more liberal with our use of the cleanup, and indeed it can be called automatically under Python 3 from a destructor in the session class. We can now, so you won't get the error explosions you might be used to in your iRODS logs from that little problem. If you forget to call cleanup on your session objects, you can now query delayed rules that are in force. You can also, or rather, we can now test our changes in an instant, pretty much. Well, within 20 minutes each time one is made, and not go through all the manual stuff because we have added hooks into the client repo for the Python iRODS client library, so that we can test it actually in a real topology with server and client being separate as well. So that's good. In the future, we'll continue to get the problems out of the library. Occasionally, there's been a good fraction of a wasted evening due to trying to keep things compatible with Python 2. We may just move to Python 3 exclusively compatibility. And of course, we'll continue to try to stay within a couple of steps behind the development of the server itself. And with that, I guess I'll take questions.
Yeah, very good. Thanks, Dan. You definitely squeezed through too. Yeah, plenty of time. Plenty of time. There are a couple of questions in the chat, but I'm going to call on Chris Calloway. He's got his hand up here. So, Chris, you want to ask? Can you unmute?
Do the new get and put methods support recursion? In other words, may I get input collections?
I think not yet. Not yet, no. I don't, have we been, Carol, have we been asked, or is that a documented?
I don't know. I assumed that it was in there, but I guess the idea is that the client itself has to walk. Is that right, Chris? Is that what you're seeing?
Correct. I have to do a get input for every single data object in the collection, and I have to construct the directories along the way.
Okay.
Ah.
And that would be handy.
Sounds like that would be a good addition to it.
Yeah, I'm surprised that the get functionality doesn't already exist. I imagine put being a convenience function, but get I would imagine would work. But yeah, I guess not, because it's not actually object semantics. It's only doing open right closes for each one. So
when you look into the breakdown of operations in the data object manager code, yeah, it's oriented toward transferring a single object.
Yeah.
So
yeah, Chris, if that's not an issue already, please write it up in your own words if you want to. But yeah, we can definitely look into that.
I will do so. Thank you.
Excellent. Let's see. We've got. Oh gosh, look at all these words. So Tony says. So Tony was originally asking about running Python iRODS client from within rules in the server, but I think what he's really asking is about, is there a good way? Is there a known kind of documented good way to have code that runs in Python that can kind of share a context? And so maybe if you had code that could run on client side, kind of share the connection, or just not have a connection on the server side. Is that such a thing? Have we heard about that before?
I mean, I'm not sure. Are we talking about a persistent context where we're communicating with, like say, a persistent server of some kind, like
right?
I mean, a persistent server connection. Is that what we're?
Yeah, I think the idea is code reusability. If you've got Python that does something interesting, but I think for the most part, people who are writing code that are inside the rules, inside the server, are going to write a different style of thing, right? You're not going to be getting and putting files from inside the server. You're just going to, talk about them or annotate them or something.
Right. I mean, okay, if the question is about Python rules and what can be done in Python rules versus Python client.
Right. Is there, I don't know that there's really much of a difference. I mean, anything once you're in the rules, you've got access to the full suite of microservices that are there on the C side.
Some things such as data movement and and using rule calls to initiate processes, say compute processes, can be done on either side.
That's right. That's right.
But if it's policy, then do it over there. If you want to do it in Python, that's great. But if it's actually policy, then it belongs in the rule engine. But the Python iRODS client can also invoke rules. So
that's right. In a way like iRule, right? It can make a client call and then fire a rule. So if that rule exists already in the server, then both have access.
Right. Exactly. You can leverage them from the client side.
That's right. Very good. Is it possible to call a rule which is defined in Python rule engine or a native rule or MSI via PRC? And if so,
Yeah.
is there any example? So the answer to that is, like we just said, yes.
I'm not sure about MSIs.
Well, so you would have to call the microservice from a rule on the server, but then you could call that rule from the client.
Yeah. Right. But rules, yeah, as long as they're registered in one of the rule plugins, the rules can be called from the Python client, yes.
Yeah. And one of the things that has surprised a few people as they've upgraded in the last couple of years is the continuation functionality. So originally, and this is what Jason was talking about with the rule engine continue, originally we had a kind of backwards compatible fall through method where if you did not specify which rule engine plugin you wanted to, which rule engine plugin you wanted to pick up the phone and do the work, the first one would pick it up. And if it didn't work, it would fall through to the next one. And then that turns out to be a little bit noisy in the logs. And so we've added now the ability, if not the requirement, not a requirement, but the ability to specify the instance name of the rule engine plugin that you would want to handle this rule call. And that way, Mustafa, you can actually call across rule languages from Python to iRODS to C++ or back again and specify and then not have those extra messages in the log file.
Now that you mention it, though, I'm not sure whether we can specify the equivalent of that -R option in iRule in the PRC. It's something we should be able to do. But...
I believe that we can. It's just part of the delay directive.
Mm-hmm.
Well, no, the delay directive can do it, but I think also, well, you're right. Maybe we don't have it.
It could be added, but I don't know whether it's in there at present.
Very good. Let's see. Mike is saying something about snake make, but we're gonna ignore him. And so we have a thumbs up on atomic metadata. So that's great. It's a big deal, and it really does. It's hundreds of times faster because of no network traffic. And of course, that original use case came out of Utrecht because they wanted to be able to
keep their
metadata templates. The metadata templates needed to remain consistent.
Right.
And you can't change one or two or three things serially and have the template be happy along the way. So
right.
that original work came out of the metadata templates working group, and then now has been put in the server, and then now the Python client has picked it up and makes this better as well. Let's see. I think, we are very interested in this parallel multi-1247 transfer. So we talked about this a little bit yesterday. We have this kind of contract between the client and the server. We're still working out exactly all the edge cases and details for that, but Dan's code is the first here in the Python to kind of implement the client side of that arrangement. And we've now got, I think you've now demonstrated with Justin success all the way through to S3.
Right.
So we're going to show that in a lightning talk tomorrow afternoon. Very good. Lots of people seem to be happy about all of this. It's good. Thank you, Dan.
Thank you.